Welcome to my YouTube channel. Let me thank all the viewers and subscribers for taking keen interest. Here is a question which many of you want to know the solution of. This is from one of the test papers which I had posted earlier on calculus. We'll understand its solution and the strategies involved. You can always join my classes and enjoy the learning. Be successful. Let us now share the solution. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, I have taken up a test question from my series of tests on derivatives. Now, this is a very important test question which involves a tangent which is actually tangent on two curves, and we need to find the point on which it is tangent. It's an application and thinking question, a challenge question if in the examination. The question here is, the line that is tangent to the curve y equals to minus x squared plus 3x plus 4 at the point P 40 is also tangent to the curve y equals to x cubed minus 6x squared plus 4x plus 16 at a point Q. Find the coordinates of point Q. You can pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given here. So I hope you have understood the question. Let us now try to find the solution. Now we're saying that the line that is tangent to a given curve at a given point is also tangent to another curve. So we can find the equation of this tangent line and then figure out at which point does it intersect or is tangent at the other curve. That could be one of the strategies. The other could be we could find the slope of the tangent for both the curves and match them. So the slope of the tangent should be same on both the curves. So that is the idea. So the strategy which I'm going to use here is the second one, which is slope of tangent same on both curves, correct? So that means I can find the derivative for each line and equate them to find the points, right? So let's do the very first one, which is y equals to minus x squared plus 3x plus 4. So derivative of this function is minus 2x plus 3. So that gives us one equation. The second equation is, let me just divide this like this, right? So the second equation will be, change the color, y equals to x cubed minus 6x squared plus 4x plus 16. And so the derivative will be 3x squared minus 12x plus 4. Now the idea is the derivative actually gives you the slope, right? So that gives you the second equation. And if we equate these two equations, we do get the slope. But we are given additional information, and that is, we are given that the tangent to this curve at the point 40. So at this point, when we have a tangent, then it is tangent to both. So let's plug in the point 40, right? So we find what is the slope when x equals to 4? Substituting 4, we get minus 2 times 4 plus 3, and that is minus 8 plus 3, right? Minus 8 plus 3, and that gives us 11. That gives us minus 5. So basically, the slope is minus 5. You get the idea. Slope is minus 5. So we could use the same slope in the second equation and find the point x. It is a quadratic equation, correct? So let's do it like that. So what I'm doing now here is, since I know that the slope is minus 5, I can equate in the second equation, right? So I'll write minus 5 here and figure out what is that point Q on the second curve. So minus 5 equals to 3x squared minus 12x plus 4, and we can now solve it. 0 equals to 3x squared minus 12x, and minus 5 comes to this side. It becomes 9. We can actually factor this. Taking 3 common, we get x squared minus 4x plus 9 divided by 3 is 3. And this can be factored further. And product of 3, so both minus, right? Minus 3 minus 1. So as you can see here, there are two possible points, right? So the two possible points on this curve are x equals to 3 and the other one is x equals to 1. Now these are the two possible points on the second curve, and what we also notice is that for these 2 points, the tangent on the second curve will have the same slope as minus 5. So what could be the point? Well, at this stage, we can find the equation of tangent, right? So let's find the equation of tangent. So what we will do here is that we'll find the equation of tangent. So I hope you understand how we are thinking and approaching towards the solution of this question. Now that is kind of important to understand, right? So we figured out a couple of things here. Let me summarize them in the next page. So we found that the line which is y equals to minus x squared plus 3x plus 4 at point 40 has a slope of minus 5, correct? This is what we figured out. And we also found that on the second line, the value x equals to 1 and 3 works for the same slope. Now definitely, we have not 2 points, you get the idea. Many times, most of the times, students actually provide 2 answers. So that becomes a huge mistake, you understand? So that is one thing you have to be very clear about. There is only 1 point, and this 1 point lies on the tangent on P40 with slope of minus 5. You get the idea. So that's fine, that equation of tangent. So let the equation of tangent be what? So we can use y minus y1 equals to m times x minus x1. Slope is known to us, so we can write this as y minus. So y1 is 0, and the slope is minus 5, x minus 4. So that gives you an equation of tangent as y equals to 5x, negative 5x plus 20. Is that clear to you? Negative 5x plus 20. Now this point, actually, whatever the value of x is there, should lie on the tangent line. You get the idea. And should lie on the curve. Correct? So we have to check the value. So if I put x equals to 1, then what do we get? If I put x equals to 1, I get y equals to minus 5 plus 20, which is 15. And if I put x equals to 3, then I get y equals to minus 15 plus 20, which is 5. So these are the 2 points. Now we have to see which one of these is on the curve, right? So we are looking at 2 points, which is 1 and 15, and the other one is 3 and 5. Now, which one satisfies the other line? That is what you need to check. And this is the part which is missed most of the time. So what we have to do here is check value of x. So in the second equation, which is y equals to x cubed, let's put 1 there. So if I put 1 there, I get 1 minus 6 plus 4 plus 16. And that gives you what? So 1 minus 6 is minus 5 and plus 4 is minus 1. We get 15. So indeed, 1 and 15 is the right value. You see that? Now if you substitute 3, you will not get 5. You can check that, right? So that becomes the point which is common to the tangent and the second line. Do you understand? That is important, right? So I'm leaving. Check for the second point. Now check to ensure that 3, 5 does not lie on second line. So that will make sure that there is only one point that lies on it. You get the idea? And therefore, our answer to this is that the point Q is actually 115. Is that clear to you? Correct? So I hope you have understood the solution. If not, you can always email me and then we can further discuss on this. Here is the illustration of the whole thing, right? So when I'm saying that the equation is this parabola, then this parabola is opening downwards as shown here, correct? In the red graph. The tangent to this at point P0 is shown by the tangent line with slope of minus 5. You get the idea? And the other curve, which is the cubic function for us, is this curve. You see that? And the point of interest. Here is the point P, which is 40. Tangent is also tangent to the curve of the second line, which is 115. Does it make sense? Of course, when you have one tangent line, then it can cut the other curve or be tangent to the other curve only at one point as shown. The other one is not the right answer. So we have the solution, and solution is that point Q is 115. Is that clear to you? So that is how we should be solving such a question. The concept should be absolutely clear that there is only one point, right? Only one point where the tangent is tangent to both the curves. You get the idea, right? So that is the key for the solution of this question. Since you have to avoid extraneous answer, it becomes critical for you to understand the concept. Thanks for your time. And if you want to learn from me, you can always send an email. If you like and subscribe to my videos, that'd be great. Welcome and thank you.